Hi there. Have you ever wondered what happens when thought itself breaks down, when reality feels unstable? In psychiatry, we don't really just see emotional distress, but we see distortions in thinking. For instance, a patient with schizophrenia, they may see connections that aren't there. A person with depression, they may struggle to see any future at all. Thought itself bends, warps, and shifts. But here's the problem. So far, we have no direct way to measure thought. And unlike heart rate or blood pressure, cognition, they leave no clear trace. We typically have to rely on questionnaires, subjective reports, and even clinicians' intuition. But what if we could go deeper? What if we could actually map out the structure of thought itself? So, how can we do that? Language is our best clue, not only because we communicate with each other all the time through speaking it out or writing our thoughts out. It doesn't just convey ideas, it technically speaking reveals how we organize the reality around us. But for years, AI and NLP have mostly treated language as just words, predicting next tokens, next sentences, analyzing the sentiment, classifying the topics in documents. Those are all very useful, but it's sometimes missing something deeper, right? Think about it. Large language models like GPT-4, they're incredible at their linguistic fluency. But does that mean they genuinely understand thought? Not quite, right? They do recognize patterns, but do they track how ideas evolve? Do they capture the belief system? How do we do inference around the world in social setting? How do we extract meaning out of everything? And this is where my research begins. What if we could move beyond surface level text analysis and reconstruct the hidden structure of cognition, like the geometry of thoughts? In cognitive neuroscience, we do face a similar challenge in perception or vision, right? Different people, they see objects differently. Like when you see a cat versus car or trees, the brain activities are going to be different, but their brains still encode fundamental patterns of similarity. We usually solve this problem using a class of method called representational similarity analysis, or RSA, which basically not by looking at raw brain activity of one particular viewing event, but by comparing the geometry of how those different concepts relate to each other. So I take this same approach to psychiatric thought, right? Instead of using AI to predict disorder like a black box model, I construct a psychometric representational space where languages, beliefs, and cognition, they can be positioned, compared, and tracked over time. This is the foundation of the COMPASS system we built. COMPASS stands for Computational Mapping of Psychometric Assessment in Speech and Semantics. Basically, it takes psychiatric construct, we place them in an embedding space, meaning the similarity between different text corpora, and which allows us to track the cognitive shifts dynamically in real time. So isn't just in theory. We have been developing and deploying those methods in real-world clinical setting. For instance, just in therapy setting, we have been analyzing therapeutic alliance, a strong predictor of your clinical outcome, and also other psychometrics of interest in CBT, psychodynamic therapy, and psychotherapy in group and community setting. And more specifically, say in family setting, we have been mapping patient-child interaction to understand their belief system and also the emotional dynamics. And now we are in an era where everybody has social media and also do teletherapy. We are also understanding how cognitive distortion spread at scale. In psychoeducation, we analyze how people process mental health information and reshape their cognitive resilience. By building those speech and NLP tools, we have been building AI-driven mental health companion system that can now provide real-time conversational support and personalized intervention that adapt to individual needs, both for therapists and for patients. And now in AI for mental health, we're also building next-generation foundation models trained on large data that integrate multimodal signals ranging from text, speech, imaging, genetics, even wearables and behavior patterns, which enables us to build dynamic recommendation system and personalize therapy strategies and intervention strategies and clinical decision making. We're not just classifying mental health conditions anymore, but instead we are mechanistically reconstructing the hidden structure of the thought itself. So let's pause for a moment. If we can now computationally map thought, we can reshape not only psychiatry but also AI itself, right? We can now design mechanistic AI system and not just respond to words, but also understand how our ideas evolve, how beliefs shifts, and how our reasoning unfolds. This isn't just about building better AI, but also fundamentally it's about understanding human cognition and even humanity in a way that we have never been before. So I believe that it is a very exciting challenge, and I believe it has the potential to transform mental health and AI research alike. Alongside this work, I have also authored two books, one on reinforcement learning methods for speech and language processing, and another one on privacy and security for large language models. Because as we're building this AI system, we must also ensure that they are trustworthy and safe. So that's the vision that drives my research. And if that excites you, let's talk.